There's a craft out there that's been flying since 2009. It's Korean-built, turboprop-powered. It skims the surface at over 200 kilometers an hour, and it holds the distinction of being the world's first wing and ground effect craft to receive full maritime classification from a recognized international body. It is known as the Aron M80, and I spoke to Charles Fewqua, who is introducing this craft to the rest of the world. Welcome to a new episode of One Wingspan Above, where we discuss anything to do with ground effect. My name is Paul Dutch. Charles Fewqua is the CEO of Patriot 3 Incorporated, a US-based defense and law enforcement contractor headquartered in Fredericksburg, Virginia. Patriot 3 exports to over 30 countries and has built its reputation on advanced tactical systems, ballistic shields, combat swimmer gear, elevated platforms. Not the most obvious home for a wing and ground effect program, but here is where it gets interesting. Charles Fewqua and Patriot 3 have not just recently discovered wing craft. They've had skin in the game since 2009, the very year the Korean company behind the M80, Aron Flying Ship Limited, begins operations. Patriot 3 were early investors. That is a 16-year relationship, and the craft they are now actively marketing, the Aron M80, is the result of every one of those years. And Fewqua is not someone describing this from a brochure. He has personally flown in the M80 3 times off the coast near Busan, Korea. That first-hand experience sits behind everything he says about this craft, and it's worth keeping in mind throughout this episode. The commercial and recreational marketing rights for North America, the GCC countries, Southeast Asia, and the South Pacific are held by a company called Aron USA. Patriot 3 is contracted under Aron USA to specifically target military and law enforcement clients, which, as you'll hear, is very much where the demand is right now. So, how did we get here? The conceptual groundwork for the Aron craft was laid at Korean Government Institute. At some point in the 2000s, Aron Company purchased the rights and the design data and began developing what would become their first production craft. Initially it was called the Aron 7. You can find footage of it online from that era. A compact 5-seat avgas-powered piston engine ground effect craft, already being described at the time as IMO Type B compliant. That craft would later be renumbered as the M50, the first entry in what Aron now calls the M series. The M prefix, incidentally, stands for military, while C designates commercial variants. In practice, Fewqua is quick to point out, they are the same physical craft. The designation reflects the intended use only, not the hardware. The M50 seats roughly 4 to 5 passengers, depending on the configuration. Fewqua noted that it's really more of an M40 in practice. But it was the starting point. The platform that proved the concept clocked the flight hours and gave the team the data they needed. From there, the development path extended to the M80, 8 seats, 2 up front and 6 in the back, and became the flagship. The craft you see flying today, the one with Korean certification, the one Patriot 3 are actively marketing. Let's talk about the M80 itself. It's a fully composite construction, twin outboard hull trimaran layout. The main fuselage sits centrally, with 2 sponson hulls extending from the wingtips. These give it lateral stability on the water, and critically house a set of electric thrusters used for low-speed maneuvering in congested harbours. More on those in a moment. Power in flight comes from a Pratt & Whitney PT6A turboprop, specifically the PTA6A34 variant, producing around 560 kilowatts. If you know anything about aircraft engines, you know that a PT6 is one of the most proven turboprops in existence. It's no accident Aron chose it. Cruising speed sits in the range of 180 to 210 km per hour. Maximum speed is around 250 km an hour. Range is approximately 650 km, with an extended range configuration pushing that closer to 970 km. The craft weighs in at a maximum takeoff weight of 4,300 kg and carries a useful load of around 1,190 kg. Fuel capacity is 650 litres of Jet A1. The flight controls are what you expect from something that lives between two worlds: ailerons, elevator and rudder. Standard aircraft control surfaces, but operated within some important constraints. In ground effect, banking is kept minimal. The reason is straightforward physics. When you're riding that pressure cushion close to the water, a significant bank angle creates unequal lift between the two wing halves. Bank too far and you slide off the cushion, with predictable results. Fewqua compared it to sitting on a table. Tilt it too far and you'll slide off. So in wig mode, turns are done primarily with rudder in a wide drifting arc. Fewqua described it as crabbing, like a hovercraft. Pitch is limited to around 10 degrees. Above ground effect, where the aerodynamics change and the craft is essentially flying as a conventional low-wing aircraft, more bank becomes available. The operating altitude in wig mode is 3 to roughly 6.7 meters above the surface. That is its sweet spot and the zone where ground effect gives the maximum lift efficiency. The wings are set close to the water, which means pressure starts building very early in the takeoff run. The craft doesn't rotate to fly, the pressure lifts it. Now those electric thrusters in the outboard hulls deserve a mention. When you're maneuvering in a busy harbour at low speed, the last thing you want is a large spinning turboprop at close range, both for noise and for obvious safety reasons. The electric thrusters let the craft move quietly, slowly and precisely, turn on its axis if needed, and navigate the dock without the main engine doing anything dramatic. Once clear of the congestion, the turboprop takes over and you're accelerating for takeoff. Certification is where the Aron M80 makes history that is generally difficult to overstate. As of late 2023, the M80 received its formal classification certificate from Korea Register of Shipping, making it the world's first wigcraft to receive full maritime classification from a recognized body under IMO regulations. Specifically, it is classified as a Class B craft, meaning it is certified to operate both within ground effect and within defined limits above it. This is the harder classification to achieve, and the more capable one. What did the process involve? Fewqua was clear that it is no rubber stamp exercise. KR inspectors were present from the very first piece of composite fabric being cut for the hull through every stage of fabrication and testing, all the way to the first flight. The entire process was documented. Given that it was the first time KR had ever certified a wigcraft, neither party quite knew what to expect going in. That experience now benefits everyone who comes after. The US Coast Guard is currently working through its own classification process for wigcraft and has the KR documentation to learn from. The approach they're taking in the US is to start with Class A, the simpler category, covering craft that operate strictly within ground effect, essentially sea skimmers. Fewqua's analogy was a corvette that can do 200 km an hour, but where the speed limit is 100. The M80 is technically capable of far more than A-class limits, but to enter the US market while the Coast Guard develops its B-class regulation framework, Aron is prepared to accept A-class certification as a first step. For military clients, this is almost a non-issue. Military operators work within operational limits regardless of civilian classification. They'll fly the M80's full B-class envelope, whether the Coast Guard paperwork says A or B, because their own safety protocols govern what they do, not civilian maritime law. There's a subtle but important distinction here between the Aron approach and some competitors. Rather than using computer systems to hard limit altitude and prevent the craft from exceeding its classified ceiling, the M80 relies on operator training and compliance. The avionics give you a full picture of what the craft is doing. There is no electronic fence stopping you from pulling back the stick and climbing above 150 meters. The limit is the license, the training and the rules. Just like a car that physically can do 100 in a 50 km an hour zone, but shouldn't, as it's not safe. Italy, worth noting, has already published Wigcraft operational regulations that in effect formally recognize the curriculum offered by Aron's in-house training center and approved by the Korean Ministry of Ocean and Fisheries Affairs. And of course, fully compliant with IMO guidelines, a significant step toward international portability of the license. Who flies one of these? What do you call them? And how do you train them? The Aron approach uses the title Wigcraft Operator, deliberately avoiding both pilot and captain, two words that carry heavy baggage. Say pilot and people think aircraft. Say captain and people think large vessel. Neither framing quite fits something that is legally classified as a ship, operates at aircraft speeds, requires maritime rules knowledge for vessel traffic, but also needs avionics literacy because the instrument panel looks like it came from a regional aircraft. The training program is certified by the Korean Institute of Maritime and Fisheries Technology under the umbrella of the Ministry of Ocean and Fisheries Affairs. They are operated through the International Wig Officer Training Center in Korea, using a training fleet that includes the M50, M80 and a water trainer variant. People who start the training include fixed-wing pilots with 400 or more flight hours, maritime deck officers of 5th class or above, and holders of light sport aircraft certificates. The hybrid nature of the training reflects the craft's hybrid nature. When you're operating below 150 meters over open water, you need to know maritime collision regulations, vessel traffic rules, and how to communicate on marine radio. But when you're at altitude, and the M80 can operate up to that 150 meter ceiling under B-class rules, you're operating in a regime that requires understanding of airspace, avionics, and the aerodynamic behavior of an aircraft. Neither qualification alone covers the job. Fewqua has flown in the M80 3 times off the coast near Busan, with the craft built at the Aron facility in Sachung. His description of the experience is worth sharing. You're on the water. It feels like a fast boat. You're accelerating, and at around 113 km an hour, something changes. The chop quiets, the hull lifts, not because the pilot pulled back, but because the pressure underneath the wings has built to the point where physics simply lifts the craft off the surface. After a few bumps, as some of the tops of the waves hit the hull at speed, everything smooths out. You're doing 210 km per hour. It feels like you're only 30 centimeters off the water, and you're sweating beads as you feel you're too close to the water, going way too fast. But in reality, you are safely skimming 2 meters off the water. If you ease off the throttle, the craft doesn't fall. It settles gently back towards the surface because the pressure cushion is self-regulating within that optimal altitude band. Fewqua asked the pilot what would happen if he let go of the controls. The pilot let go. The craft flew itself, tracking level on the cushion, maintaining altitude, pointing straight ahead, stable. That is the goal. Boring is good. A flight that requires constant attention and active correction is a flight with a problem. A flight where the pilot can let go and the craft maintains itself is a flight that is working as designed. This matters enormously for public acceptance, where craft have a perception problem. They look fast and low and borderline reckless. The reality, as anyone who spent time studying the aerodynamics will know, is that ground effect is intrinsically stabilizing if the craft has been designed properly. The closer you get to the surface within the design altitude band, the more lift increases and pushes you up again. The craft is in a self-correcting equilibrium. Now that said, takeoff is not without its demands. The M80 has demonstrated takeoff and landing in wave heights up to 1.8 meters. That figure is real, but it requires context. A 1.8 meter swell and a 1.8 meter chop are two very different sea states. Rollers can be timed. An experienced operator can read the pattern, finds the trough, and uses the long flat back of a wave as a runway. Fewqua's summary was pragmatic. If boats aren't going out, you probably aren't either. The M80 is not designed for heavy seas. It's not a North Atlantic vessel. It's fast, efficient, and capable in sea states where it was designed to operate, and honest about its limits beyond that. An automated stabilization system is currently under development that would assist operators during gusty landing conditions. Computers react faster than humans to sudden crosswind gusts, but manual override remains always available. For now, the operator reads the water. With time, AI in this new system will learn from thousands of takeoff and landing cycles and begin to assist. But that technology needs to be trained first. The Aron program has accumulated 2,000 plus flight hours, more if you count displacement mode at sea, and 200,000 kilometers of operational distance across its M50 and M80 fleet. That is not a trivial data set. That is hard-won knowledge of what happens when a wing touches the water before the hull does, what a jolt at speed feels like through a composite structure, what sea spray does to a turboprop intake over time. Several design choices reflect that experience. The wing design allows the craft to glide at a 7:1 glide ratio. That means that in an event of complete power failure at cruise altitude, you are not falling from the sky. You are a glider settling gently towards the water, which is already very close. The composite structure is built to absorb hard landings and off-axis impacts. The outer hulls of the trimaran gives you capsize resistance that a single hull design cannot match. Even if that load is asymmetric, one side hits before the other. Fewqua reflects as someone who has dealt with exactly that kind of asymmetric landing events in their own test program. One outboard wing would touch the water fractionally before the hull, creating an asymmetric side load on the structure. If the craft then still is generating lift on the other side, and there is a differential, that can break the craft if it's not designed for it. You will always need to take this into account. Welcome to the testing phase. These are the lessons that make the next design better. The Aron program went through its own hard lessons in the early years. That is why the flight hours experience matter. The near-term focus is the M80 and the M120. The M120 is, as Fewqua put it, a stretch M80. The molds already exist, the design is finalized, and production can begin as soon as orders arrive. It seats 12 2 crew up front, 10 passengers in the main cabin, with the same basic configuration as the M80 scaled up. A more powerful engine variant is being evaluated for the M120, particularly for military applications where payload and performance margins matter. The M250 is a larger step, 25 seats, entirely new molds required, probably a 2-year build time from contract to delivery. But the design is finished, and Aron is ready to move when a customer commits. The numbers in each destination, by the way, roughly represents passenger capacity, with some rounding, and the caveat that all of them can be configured as pure cargo carriers if required. And that's the difference between the M and the C series. In the meantime, Aron has developed larger, lower doors for casualty evacuation and medical evacuation, addressing military and commercial mission requirements. Composite construction allows easy modular fuselage modifications, including dual doors and open cockpit options for unique recreational uses. Aron has ruled out hydrofoils despite their potential to reduce takeoff distances, focusing instead on advanced hull designs that manage turbulence and cavitation to overcome hump drag. The company monitors competitor innovations like blown wings and foil-assisted designs, but maintains a conservative approach to ensure safety and durability. Meanwhile, a battery-powered M80 variant is in development, driven by a specific commercial customer request. Expected completion mid-2027. Fewqua is realistic about the trade-offs. A full battery weighs the same empty as it does full, while a fuel load decreases as it's burned, making the craft progressively lighter and more efficient as range increases. For long-range and military applications, the turboprop stays dominant. For shorter commercial routes where emissions and noise matter, the electric variant opens new markets. And then there is the Max, Aron's Wig drone, currently in development, 5.5 meters wingspan, payload capacity of approximately 136 kilograms. Critically, petrol-fueled, not battery-powered. In military terms, that means rapid refueling in the field, extended range, and operations in locations where electrical infrastructure does not exist. A fuel bag can be dropped from a C-130 into the ocean. The Max can land, refuel, and be airborne again. A battery-powered drone cannot do that. The payload gap between the Max and the competitors is significant. Fewqua cited a competitor drone with a payload of roughly 23 kilograms. The Max targets 136 kilograms, a 6-fold difference, driven entirely by the energy density advantage of petrol over current battery technology. Aron is establishing full US manufacturing in 2027, driven primarily by that military demand. American defense contracts typically require domestic production, and local manufacturing removes the logistical complexity of shipping completed craft from Korea. The demonstrator will be built in the United States. Aron is targeting spring 2027 for the arrival of the US demonstrator craft, a concrete milestone for North American market growth. That craft won't just sit in the hangar. Once Aron's US manufacturing facility comes online in 2027, US-based training is expected to follow, bringing the process onshore for North American military and commercial clients. And the demonstrator will be the centerpiece of training, marketing, and regulatory engagement efforts domestically. Given the Coast Guard, potential military customers, and commercial buyers something that they can actually see, board, and evaluate on home soil. Production focus initially targets military contracts, with commercial sales expected to ramp as certification processes and demand matures. The Korean factory isn't going anywhere though. It stays operational to serve Asia-Pacific markets, and its location makes strategic sense. Proximity to the South China Sea is exactly where the significant portion of military interest is concentrated right now. As for Europe, that decision remains open. For the moment, the focus is firmly on the Americas and adjacent regions, with everything else deferred until the North American operation is established and running. So why is this all happening now? Wigcraft have been technically viable for decades. The physics haven't changed. Why are we suddenly seeing multiple credible programs? Aron, Airfish, REGENT, all gaining serious traction at the same time. Military interest in fast, low-signature, shallow draft maritime platforms has intensified sharply as tensions in that region have escalated. A craft that skims at 200 km per hour at 2 meters above the water surface, carries significant payload, has a minimal radar cross-section, and doesn't require a runway or port infrastructure, is not a novelty in their context. It's a serious operational capability. That military pull is doing two things simultaneously. It's providing the commercial justification that makes programs like the M80 viable. You need someone willing to buy at scale to fund the certification, the manufacturing infrastructure, the training system. And it is legitimizing the technology for the commercial sector, which follows military adoption with some lag. But there's something else going on at the moment. And here Fewqua was generous with his acknowledgement of REGENT's role. REGENT, with their advisory board of retired admirals, their significant venture capital backing, and their aggressive public-facing marketing, has done something that smaller, quieter programs like Aron have not yet done at scale. They have made the concept real to a wide audience. People would never have heard the phrase wing and ground effect, are now familiar with it because of REGENT's visibility. In Fewqua's framing, Aron and Airfish travel in REGENT's wake, not as followers technically, but in terms of public awareness and commercial momentum. REGENT is breaking the egg, and that benefits everyone in that space. The concern shared by Fewqua, and frankly by anyone paying attention, is that a high-profile failure, a fatal accident, a dramatic capsize on camera, could close that window just as it opens. That is not a reason to stop. It is a reason to be rigorous, to share lessons, and to build the kind of operation track record that turns "that looks dangerous" into "that's well understood and safe." 2,000 plus hours and 200,000 kilometers is the beginning of that story. 16 years. A Korean government institute concept, an early stage investment from a Virginia defense contractor, certification process so thorough that the regulator was learning the rules as they were being written, and now 4 or 5 craft in the water, a US manufacturing facility on the horizon for 2027, military customers circling the M120, and a turboprop wig drone under development. The Aron M80 is not the flashiest entry in the skim machine space. It doesn't have hydrofoils, a blown wing, or a Silicon Valley marketing budget. What it does have is a piece of paper, a Korean classification certificate, that no other wigcraft currently holds. And it has a pilot who can let go of a yoke at 210 km per hour, 2 meters above the water, and just watch. If you're not a military procurement officer, or commercial ferry operator, Fewqua had one more use case that might be of interest. The pitch: fly out to a shallow sandbar somewhere in the Bahamas that's too far for a normal boat to reach. Step out onto the wing, have lunch, snorkel, then climb back in, throttle up, and you're airborne again. It's not the primary market, but it might be the most honest answer to the question of why would anyone want one of these things. And this lands differently than any spec sheet ever could. I want to thank Charles Fewqua for his time and his openness. I'm sure to keep an eye out on cheap flights to Korea so that I can fly in an Aron craft and report back on the ease of flying one myself. Until then, keep on skimming.